Rock is thrown with an initial horizontal velocity of 40 meters per second off a cliff that's 20 meters high. Determine how long it takes for the ball to hit the ground. So we start off. Let's draw a picture of what's going on here. So we have some sort of cliff. Okay. A rock is being thrown off. So this is my rock. And it's getting thrown off the cliff. It has an initial horizontal velocity of 40 meters per second. All right, the cliff is 20 meters high. All right, and I need to find the time, so we're looking for t. So let's set up our variables, use that word method. So we have vi, oops, scratch that. We have the VIY, so the initial vertical velocity. We have the VIX, the initial horizontal velocity. The VFY, the final vertical velocity, which we don't really ever use, but I'm just listing it there so we don't get confused. The VFX, look at me here, making all these mistakes. So the final horizontal velocity. We have the AY, the acceleration in the vertical direction. The AX, the acceleration in the horizontal direction. The DY, that's how high it is. The DX, that's how far it goes. And time, which is the same in both cases. So let's figure out what things are equal to. So initial vertical velocity. This is always 0. Final vertical velocity. In this case, we don't know it. We'd have to figure it out. Acceleration in the y direction. This is always 9.8 meters per second squared. dy, how high up the object is. Its displacement in the vertical direction. That's 20 meters because the cliff is 20 meters high. And time, we don't know. Its initial horizontal velocity. Well, they told us that was 40 meters per second. The final horizontal velocity, well, this is also 40 meters per second because the horizontal velocity never changes. It never changes because the acceleration is always 0. dx, how far it goes, we don't know, and time is going to be the same. So in this case, we have to look which set of variables will we use to solve for time, and in most cases, we're going to use the vertical set because we have more information to work with. So we're going to use this formula. dy is equal to VIY times t plus 1/2 AY times t squared. Now you guys will have to show units every step through. I'm going to try and show units. I'll see if it's taking me too long. I may cut it down. So dy, 20 meters, equals VIY, which is 0, times t, plus 1/2 AY, which is 9.8 meters per second squared, times t squared. So I have 20 meters is equal to 0 times t just turns to 0, plus 1/2 times 9.8 turns to 4.9 meters per second squared, times t squared. All right, the 0 is just going to drop off. So if I want t squared by itself, I have to divide each side by 4.9 meters per second squared. All right, so in the end, 20 divided by 4.9 is giving me 4.08 equals t squared. Take the square root of that. And I get the time is 2.02 equal to t. So there we go. I found my time. All right, 2 left. So don't save that. Let's see here. So in this question, a cart rolls off a table that's 2.6 meters high. The car had a horizontal velocity of 4.5 meters per second. Find how far the car landed from the table. So let's draw a little table here. I have some kind of cart, and it's rolling off the table at 4.5 meters per second. The table was 2.6 meters high. So set up my variables. VIY, VFY, even though we never really use it, AY, DY, and T. I have my VIX, VFX, AX, DX, and T. Now in this case, find how far the car landed from the table. In this case, we want to find where did the car end up. It's going to roll off the table, something like this, and it's going to wind up a certain distance from the table. That's its dx. So this is what we're looking for. But in most cases, in order to find this, you have to find time first. So let's plug in, see if we can find for time, and then we can plug it in and solve for dx. So VIY, this is always 0. VFY, I don't know it. We'd have to figure it out, but we're not going to need it. AY, it's always 9.8 meters per second squared. DY, they told us the height of the table, it was 2.6 meters. Time, we don't know. VIX, this is 4.5 meters per second. VFX, this is also 4.5 because the velocity in the horizontal never changes. AX is 0, it's always 0. DX we're solving for. So first let's solve using the y variables, and let's solve for time. So DIY equals VIY times t plus 1/2 AY t squared. DIY was 2.6. This is 0. It's always going to be 0 because the VIY is always 0. So this is going to be 0 plus 1/2 9.8 meters per second squared times t squared. All right. 2.6, and that was meters, is equal to 4.9 meters per second squared times t squared. Divide each side by this 4.9. 2.6 divided by 4.9 is equal to 0.53 second squared equals t squared. Take the square root, and we get that 0.73 equals t. All right, so I'm going to take that 0.73. It's the same for both. And now I can, let's use blue, this purple color. Now I can use these numbers and solve for dx. So I'm going to set up an equation again. This should just be dx. And what we're looking for, the range, is equal to VIX times t plus 1/2 AX t squared. All right, dx we don't know. VIX was 4.5 meters per second. Time was 0.73 seconds. Plus 1/2 AX is 0 times t squared, so 0.73 seconds squared. Now this piece is always going to drop off because the A is always 0. When we're talking about the horizontal, the A is always 0. So in the end, it's just going to be dx is equal to 4.5 times 0.73, which is equal to 3.285. So we're going to round that to 3.3 meters. So that's the range, how far it falls from the table. All right, one more and we're good to go. Let's copy this. All right, a stone is thrown from a cliff with a horizontal velocity of 12 meters per second. The stone hits the ground 30 meters from the base of the cliff. All right, so this is different information than we normally get. So if I have some sort of cliff, I have a stone that is thrown, right, at 12 meters per second. Now, in this case, they're telling us the stone hits the ground 30 meters away. So that's our 30 meters. That's our dx. That's our range. So let's set up our variables and then see what we have. So VIY, VIX, VFY, VFX, AY, AX, DY, DX, and then T, which is the same for both. So VIY, always going to be 0. VIX is equal to 12 meters per second. VFY, we don't know it, probably not going to need it. VFX, also going to be 12 meters per second. AY, always going to be 9.8 meters per second squared. AX, always going to be 0. DY, we don't know it. This is what they're asking us to solve for. DX, in this case, we know it. It's 30 meters. Time, we don't know it. So, in this case, in order to figure out dy, we're going to need to find time. In order to find time, we're going to have to use this set of information first. So let's set it up. Dx is equal to Vix times t plus 1/2 ax t squared. Dx is 30 meters. They gave us that. So 30 meters is equal to Vix is 12 meters per second times t plus 1/2 ax is 0 times t squared. Since this is 0, this whole chunk is going to drop off to 0. So I just have 30 meters is equal to 12 meters per second times t. If I want t by itself, divide each side by 12 meters per second. Cancels out. 30 divided by 12 is equivalent to 2.5 seconds is equal to time. So I found that t equals 2.5. So that means that this t is also 2.5 seconds. And now I can use these variables and solve for dy. So dy equals VIY times t plus 1/2 ay times t squared. Dy we don't know. VIY is 0 times t plus 1/2 9.8 meters per second squared times t squared. So that's 2.5 seconds squared. 0 times t is going to be 0. 1/2 times 9.8 is going to be 4.9, but then we have to multiply that by 2.5 squared. So let's see. 2.5 times 2.5 equals times 9.8 times 0.5. So in the end, I'm getting dy is equal to 30.6 meters. All right, guys, I hope this helped. Hundreds for everybody tomorrow, right? All right, take care, guys.